Okay, let's see, is the audio working? Yep, it is working. That is good. So, welcome back, everyone. Today, wait, let me turn on shuffle play. Okay, yeah, here we go. So, welcome, everyone. Today we're going to be continuing. We're going to be doing instancing, the depth buffer, and hopefully I'm going to cover model loading today. This is going to be the biggest one and probably the most complicated, but hopefully I'll be able to do it. So first, let's go to instancing. Before we start, let's see what we finished on yesterday. Oh, this is a test project. Let's see, where is it? This. So yesterday we finished on making a camera and drawing textures. So let's see. Everything still works. If you can see, you can zoom in, you can rotate our camera, zoom out. Yeah, it's pretty nice, I'd say. Okay. Hello, Nakomi. Good to see you here. I know you usually don't stay for a while, but it's always nice to see you. Okay, so we have this done. Let's see what is instancing. I'm gonna first try to explain myself. Actually, I'm not gonna try to explain myself, it's pointless. It's gonna be harder to understand. If there is something that I see that should be explained, I will explain. Okay, let's close all of these functions. This. Okay, so only the render function. Our scene right now is very simple. We have one object centered at 0, 0, 0. What if we wanted more objects? This is where instancing comes in. Instancing allows us to draw the same object multiple times with different properties: position, orientation, size, color, etc. There are multiple ways of doing instancing. One way would be to modify the uniform buffer to include these properties, and then update it before we draw each instance of our object. We don't want to use this method for performance reasons. Updating the uniform buffer for each instance would require multiple buffer copies for each frame. On top of that, our method to update the uniform buffer currently requires us to create a new buffer to store the updated data. That's a lot of time wasted between calls. If you look at the parameters for the drawIndexed function in WGPU docs, we can see a solution to our problem. So indices range U32, base vertex instances. This right here. Yeah, if we go to drawIndexed, this is this function. Instances, right now we're doing a range from 0 to 1, which basically means only one instance. So let's see. The instances parameter takes a range U32. This parameter tells the GPU how many copies of instances of the model we want to draw. Currently, we are specifying 0 to 1, which instructs the GPU to draw our model once and then stop. If we use 0 to 5, our code will draw 5 instances. I think we can actually check this out. It's not going to be very different, but the problem is that we're not going to see like each instance separately because all of them are going to be drawn in one place. Yeah, as you can see, it looks absolutely the same. Okay, let's revert this change. The fact that instances is the range U32 may seem weird, as using 1 to 2 for instances would still draw one instance for our object. It seems like it would be simpler just to use the U32, right? The reason it's a range is that sometimes we don't want to draw all of our objects. Sometimes we want to draw a selection of them because they're not in the frame. Or we're debugging and want to look at a particular set of instances. Okay, now we know how to draw multiple instances of an object. How do we tell WebGPU what particular instance to draw? we're going to use something known as an instance buffer. Let's see, the instance buffer. We create an instance buffer similarly to how we create a uniform buffer. First, we'll create a struct called instance. Okay, let's see. Where are we creating our... So this is the camera uniform, yeah. So let's create it above it. Right, I guess right after the vertex. So this is going to be a normal struct, instance. It's going to have a position and cgmath vector 3 f32. What this means is that, and also rotation. What this basically means is that the things which are going to be different about each of our instances is going to be their rotation and their position. So all of them won't be drawn in the same place. Mass is defined multiple times. Let's recall this to state instance. What? Wait a second. What the hell just happened? Huh? Huh? What the hell just happened? I'm so confused. My phone is breaking. What the hell is happening? I'm gonna go put it on a charger. Just a second. Okay, I'm back. That was weird. Okay, let's continue. So we create an instance. As I already said, the things which are going to be separating each of our instances is where they're located and how they are rotated. A quaternion, quaternion is basically rotation. Using these values directly in the shader would be a pain, as quaternions don't have a WGSL analog. I don't feel like writing the math in the shader, so we'll convert the instance data into a matrix and store it in a struct called instance raw. I usually call it MVP, but let's follow what it says here just. So you create a new representation, C. We're going to be deriving from clone, that will require a copy, and some bytemax stuff, which means that we're going to probably be passing it. Oh yeah, we are making a buffer. I already forgot. Zerable. And it's going to be a struct instance raw state instance. And just to keep the same naming scheme. It's going to be a model. Why does it do a matrix here like that? I guess it's going to be easier to pass in, maybe using bytemap. It's easier for bytemap to understand it. Probably. Let's see. So this returns no error, but if we do cgmath matrix for f32, yeah, I think bytemap doesn't like it. Yeah, it does not implement pod. Okay. Let's then use this normal 4D matrix array. Let's implement for our state instance, not for this. Oh, okay. So we implement for state instance function to raw. It's going to take the self, and it's going to turn an instance raw. Instance raw is a model of cgmath matrix for from translation. This is basically we're creating a 4D matrix from the position. So yeah, we specify the position, and we multiply this by CG math matrix 4 from quaternion probably, from rotation, from, okay, let's see what the function name is. Oh, from, okay, it's just from self dot rotation. And in the end, we turn it into the array. Okay, let's see, what's the problem now? And it needs to return a reference? Nope, what's the issue? Cannot find, oh, yeah, because I named it state instance raw. Now we need to add two fields to state, instances, and instance buffer. So let's go here. Let's see where we're going to be doing it. We're going to be doing it right after index buffer. So instances, it's a vector of instance, and instance buffer is going to be a WebGPU buffer. Okay, so it's going to be the same buffer as index, vertex, so we're going to be creating them the same. I mean, yeah, makes sense. To import, the CGMath crate uses traits to provide common mathematical methods across its structs, such as vector3, which might be important before these methods can be called. For convenience, the prelude module within the crate provides the most common of these extension crates when it is imported. To import this prelude module, put this line near the top of librs. Okay. Okay. So it's the CGMath, prelude, and everything. We'll create the instances in new. We'll use some constants to simplify things. We'll display our instances in 10 rows of 10, and they'll be spaced evenly apart. So let's go to here. Const num instances per row is of type u32. We have to specify the type as this is a constant. Instance displacement CGMath vector 3 f32. This is going to be instance displacement CGMath vector 3 new number num instances per row as f32 multiplied by 0.5. Okay, let me do this on a new line. So this is going to be multiplied. Oh wait, first of all we have to say this is an f32 multiplied by 0.5 0 0, and same thing here. Is it the same thing? Yep, it is. Sick. Did I misspell something? Number of instances. Still no. Okay. Cannot find number of instances in the scope. Do I need to use self? Self capital S. Oh, okay. Self number of instances in row. So okay, wait. Okay. Now we can create the actual instances. Let's see, we're gonna be creating them. Do we need anything from others? Doesn't seem like we do. So I'm gonna create it before we create the camera. Yep, here, where we create all the other buffers. Okay, let's instances be equal to self create state instances. Am I gonna be taking anything in? Doesn't seem like I am. Yep, doesn't seem like I am. So instances, we're gonna close this and call the function. I mean, not call the function, create a new function. Function create state instances. Wait, there's already. Oh. Create state instances. Oh, vec. I'm not gonna be keeping this code after this tutorial, I guess. So it doesn't really matter, as long as I can understand it well enough. Okay, so this takes no arguments, but it's gonna return, so 0 to number of instances per row. I'm gonna be creating flat map. Why call it Z? Oh, okay, I guess, wait, I get why it calls it Z. I guess there's also gonna be an, nope, there isn't. Okay, no, nothing. So here we go again. Oh wait, no, there is X. Yeah, I was searching for it. Okay. Self number of instances per row. Map. We're gonna take X. Let our position be equal to cgmath vector 3. X is gonna be X is F32. Y is gonna be 0, 0, and Z is gonna be Z as F32. Is this a return? Oh, minus instance of self instance displacement. Okay. I can use semicolons, yes I can. Let rotation, okay, I hate this part, this is so boring. Position is 0, then cgmath, Quaternion from axis angle, cgmath, vector 3. I need the vector 3 to be, oh my god. From unit Z. And this is going to be cgmath. This is going to be degrees. Yay, I guessed it. Degrees of 0. Oh. Else cgmath Quaternion from axis angle position normal. I cannot normalize the position. Oh, it doesn't know what it's set to. It equals. No, it does know. It knows that it's a vector. Oh, I misspelled this, vector 3. So position dot normalize and cgmath degrees 45. Degrees 45 0. Alright, this is not returning. Oh wait, it is returning. Okay. So I'm gonna do this. I mean, it's not returning here, it's assigning to rotation, so it makes sense that there are no semicolons, but there's a semicolon there. Instance, a position, rotation. Then in the end, we collect all of these into a vec like this. this returns WGPU instance. It's a vector of WGPU instance. So this is set. Let's see what's the problem here. First of all, this is CG math instance. This is going to be a state instance again. So state instance is 0. Okay, done with this awful function. Let's see. So rotation, if the position is 0, then we assign angle of 0 degrees. Else, by the z-axis. Else we're gonna do 45 degrees by wherever it's looking, I guess, where the vector is pointing. The position vector, which should be yeah, basically it's gonna rotate in the direction it's looking. So let's go up here where we actually call the function. Yeah, create instance. Now that we have our data, we can create the actual instance buffer. Let's see. So instances, iter, instance draw, collect. Let instance data be equal to instances dot iter map instance to state instance to raw and then collect all of them into a vector. So this becomes a vector of state instance raw. Oh. What do you mean my stream isn't available? What happened? Oh, it's just Twitch glitching out for me. Let instance buffer be equal to device dot create buffer visualization WebGPU. Oh my god. WebGPU utilities buffer init descriptor label is going to be some instance buffer, and the contents are going to be again byte slice of our instance data, and our usage is going to be WebGPU buffer usages vertex. Oh, not forget the semicolon. So create an instance buffer. This is very similar to creating other buffers. For example, the vertex buffer, you also get a byte slice, and in the index buffer we do the same but for indices. What we're using it as a vertex. We're going to need to create a new vertex buffer layout for instance raw. Wow, again a lot of code. Let's see if I can guess what all of this does. Let's go down. Oh, wrong page. Okay, does end not work? Okay, now it worked. So for instance raw, we do the same thing, I guess, that we did for a vertex here. It has different shader locations, size of. I think I'm gonna do it the same way as I did here. Let's see. I'm gonna try to do it. I learned a new thing, and I'm gonna try to use that new strict thing. So implement for state instance raw, I'm going to be doing a const attributes, attribs, which are going to be of type WebGPU attribute, WebGPU vertex attribute. We're going to need 1, 2, 3, 4 of these. Is this borrowed, this constant? No. Okay. It's going to be equal to WebGPU attrib, no, what is it? Vertex attribute array. And in here, we're going to specify that phi is going to be WebGPU vertex Wait, how do I do this again? Oh, I can just say float 32x4, then 6 is going to be float 32 again times 4. 7 is going to be float 32 again 4. Okay, what is this happening? A matrix vertex 4 vertex slots, as it's technically 4 vectors. Oh yeah, makes sense. So I can just, I guess 8 is also going to be float 32, 4. Okay. Let's do this. Now, what's the issue? I mean, oh, commas, not semicolons. In case we create the attributes, and create a function description where we're going to be returning WGPU vertex buffer layout. It's going to be static. We're going to be using std memory, WebGPU, vertex buffer layout, array stride, memory size of instance raw as WebGPU buffer address. Step mode is going to be WebGPU vertex step mode instance, and our attributes are going to be a reference to the self attributes that we made there. This should be it, right? Yep, so this is vertex step mode instance, size of state instance raw. So this, basically the info we're going to be passing in, which we calculate from the normal state instance. Okay. We need to add this descriptor to the render pipeline so that we can use it when we render. So let's see, where we're creating render pipeline is creating render pipeline here. And our vertex buffers, we have to pass in not only the vertex description, but also the instance raw description. Okay. And also we have to return our values. So instances and instance buffer. Mismatch types, expected struct. Wait, what actual type is it here? The one which we're going to be passing in state is a vector of instance. Man, why do they need an instance? It's not an instance. It's a state instance. Okay, let's see where we're doing this. State instance, right? Okay. No errors. We did this, we did this, we did this. Make sure that you add new instances to the vector. You recreate the instance buffer as well as camera binary group. Otherwise, your new instances won't show up correctly. Make sure that if you add new instances to the vector, you create the instance buffer as well as camera bind group. Otherwise, your new instances won't show up correctly. So every time I create a new vector, I'm gonna have to recreate these two. Okay. Not add a new vector, add a new value to the vector, I mean. So let's see, so using a render pass of set vertex buffer before we set the index buffer. Shapes even, okay. We're gonna do render pass dot set another vertex buffer. Oh, set vertex buffer. This is gonna be self instances dot slice bounds all. The buffer slice is WGPU index format uint 16. Let's see, arguments to this method are incorrect. Oh, we do not need this. Like that, yep, okay, that's good. We need to reference the parts of our new matrix in shader WGSL so that we can use it for our instances. Why did the music stop? I just noticed. Wait a second. I think I made the volume to 0 by accident somehow. I thought it was a little bit too quiet. Okay. Oh. So we create an instance input. We need to reference the parts of our new matrix in shader WGSL. So let's open that. I think we're gonna need this for now. So we create a struct instance input. Struct instance input location 5 is model matrix is 0 type spec 4 at 32 bam 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 bam. This is gonna be 3 2 1. This is 6 7 8 10 10. We need to reassemble the matrix before we can use it. So let's see, we also pass, except for the model, we also pass an instance input. I wonder if the parameters here are dependent. They're probably dependent, now that I'm thinking about it, on the way we set them up here. So for example, if we pass in first the state instance, then we're gonna have to do instance input first, but otherwise we're gonna have to do vertex input first. Probably. So we create let model matrix be equal to a met 4x4 F32. Oops. Like this. Instance dot model matrix 0. Let's copy. Oh my god. Oh, we apply the model matrix before we apply camera uniform view projection. We do this because camera uniform view projection changes the coordinate system from world space to camera space. Okay, yeah, makes sense. So first we change the world coordinates, then we change the camera coordinates. Our model matrix is a world space transformation. So we don't want to be in camera space when using it. Okay. See, so this is multiplied model matrix. We'll have a forest. I don't think I'm gonna have a forest as I'm not using trees, but still. Let's see, cargo, run. I have a feeling I might have a okay, let's see. If I copy this code and paste it here instead of what I did, let's just go to the end quickly. So instead of this, I comment this out and put this in here. Just don't forget to change this to state instance raw. Nope, it's still the same thing, so I did this correctly. Let me revert the changes. So what could be the problem? What could be the problem? I guess only the last instance is being drawn. Let's copy this. Let's just do it like this without the function because I do not like the function. Whereas our create this, delete it. Let's go to or create the instances. This. We just have to rename this to state instance. Oh yeah, and this is self capital S. Copy this and go here and here. Let's see. I'm not changing that much. Probably just rewrote some code incorrectly. Still though, still. Instance data. Let's see where this is being used. Instance buffer, device create buffer, init, WGPU tool buffer, init description, label some instance. First of all, this is spelled incorrectly. Buffer, instance data, buffer usages, vertex. Okay. To raw. We collect all that. Maybe my to raw function is incorrect, which is probably not the case, but you never know. So it's cgmath from translation or position multiplied by this. Let's just copy this line just to be sure. It didn't copy. Okay. Still 1. 4 by 4. Vector 3 quaternion. Let's copy, yeah, these two constants Maybe they are incorrect somehow. And can I just, instead of using self everywhere, just define them in the beginning here? Does it allow me to do that? Yep. Then I just remove self from here so it's more readable. Okay. Maybe this will fix the issue. Nope, it doesn't. Maybe there's somewhere. Nope, they're not somewhere. Something weird is happening. So I create the instances correctly. I can even copy this, okay. At least until I fix the issue, I'm gonna use this code. Save this. Oh, I forgot to rename this to state instance raw. Still probably not gonna work, right? Oh. We're assigned to shader 5. Five, 6, 7, 8. And what was the error again? Device create render pipeline error. 2 or more vertex attributes were assigned to the same location in the shader 5. Huh. Create render pipeline. So it doesn't like this. Let's see. Let's go to vertex description. Oh, I'm using. I copied this in the wrong place. This is supposed to be here. State instance raw. Okay. Nothing changes. I mean, it makes sense. It's the same thing that I've done here. Okay. So render pipeline. I mean, I checked recently. It seems to be doing fine. Let's remove all of these useless things here. Oops. Why am I using the instance? What? I'm not supposed to be using it anywhere. Oh, that instance. Okay, I am supposed to use that instance. Okay, I just finished making food. Oh, that's great. I have no idea how long ago this was. I just focused on this error. And yeah. Trying to fix it. What did you cook for yourself? If you don't mind me asking. Literally now lol. A simple salad. Salad, not salad. Wait, is there a thing called salad? No, it's salad, but okay. A simple salad with cheese and tomatoes. Does this salad consist of only cheese and tomatoes? Because that's a weird salad. Oh, I don't like white cheese. Oh, I didn't see this. Yeah, self-instance.land, it only draws one. I'm so goddamn stupid. So goddamn stupid. So instances is gonna be from 0 to self amount of instances dot len as this. I don't know why I need to do that. Okay, so now it should work. Yep, it's beautiful. Okay, now let's return this code here that I had, because I don't like this large piece of code. I like using macros. Recently learned them and already using them. Amazing stuff. Yay, now we have a forest of phoenixes. I'm searching for any 3D imperfections right now because we're not using a depth buffer, so some parts should look wonky, but it doesn't seem to be that way, weirdly. Let's see, is anything clipping? Oh, I forgot to set up the magnifying tool. I'll do it for the next stream. Oh yeah, you see this edge? It's pretty difficult to see, but this edge is supposed to be behind this phoenix. Instead of it, it's in front. Yeah, so that's the problem with the depth buffer, which we're gonna do next. Oh wow, you made a 3D thing? Yeah, it's a 3D thing. But right now, as you can see, yeah, wait, let me show you. As I already showed, like, literally right now, because we're not using a depth buffer, which says which should go in front of what, there are imperfections like this, or stuff which should be behind is drawn on top. So as you can see, this is technically behind it, but it still draws on top. It's pretty funky looking. Right, let's see, poorly set up depth buffer. Probably not gonna be any nice images here. Okay, fine. I already showed it, so there's no need to find something else. Sorting from back to front. This is the go-to method for 2D rendering, as it's pretty easy to know what's supposed to go in front of what. You can just use the Z order. In 3D rendering, it gets a little trickier because the order of the objects changes based on the camera angle. A simple way of doing this is to sort all the objects by their distance from the camera's position. There are flaws with this method though, as when a large object is behind a small object, parts of the large object should be in front of the small object, will be rendered behind it. We'll also run into issues with objects that overlap themselves. If we want to do this properly, we need to have a pixel per pixel level precision. That's where a depth buffer comes. You actually have to create a depth buffer here. Wow, in OpenGL, just write one line of code like enable depth buffer, and it's like, yeah, sure, bro. Okay, let's see. So we have to go to our texture. Why is this? It says that it's never used. Okay. We create a new constant. Let's close these two functions as we're not going to be needing them. public const depth format. It's a WebGPU texture format. Texture format, depth 32 float. I'm actually wondering, yeah, this is set software and game development, because last stream I had this set to just chatting, and that's why I wasn't getting like absolute anyone here. At least now that I'm getting one new person per stream, that's already good. I mean, they're not really chatting, I just see them come in and then go out. Okay, water break, by the way. Don't forget to drink your water, kids. Let's close this. Let's continue. Public function. We create our depth texture. From device, we need WGPU device. We also need the config, which is probably the texture config. Oh, surface config, not texture config. What? We need to redo all of this? Create. Doesn't this do the exact same thing though? Oh no, it doesn't. Okay. Extend 3D. Width is going to be our config width. Height is going to be our config height. Depth or array layers. One only. One. Oh yeah, because it's a 3-dimensional texture. Description. WebGPU texture descriptor. So label some. We pass in the label. Oh, I did not see everything, I guess. So label as a reference to a string, and we also return self. So this is going to be sum of label. Size is going to be oops. Size is going to be size. Map level count is going to be 1. Sample count is going to also be 1. Dimension. WebGPU texture. Dimension D2. By the way, yesterday I asked myself a question: why is it D2? I was thinking for it for like a big portion of the stream. I'd say like 10 minutes. And I don't know why it took me so long to just realize that variable names cannot start with a number. I have no idea why it took me so long to figure that out. Okay, these are, no, render attachment is not new, but texture binding is new. Okay, let's create our view. Texture create view description is going to be WebGPU. Texture view descriptor. Oh, default. Okay, so this thing is not needed here. Then let's remove this. And a sampler. Let sampler equal to a device dot create sampler. Oops. And I keep mistyping the end symbol with the add symbol. Address mode. Okay, all of this is going to be clamp to edge. Just don't forget to set this to V. W. Basically the same thing we did with our old texture. I mean, not old textures. I mean, linear. Let's see, then it's a min filter. I prefer min filter being first. All of them are actually linear. That is not the same as when we're creating a texture when our min filter is actually nearest. Our mapmap filter is nearest though. Filter mode, nearest. And this time we're actually going to be setting our compare function and the other variables we didn't set last time. Level of detail, minimal clamp, and our level of detail maximum clamp is going to be 100. Let's see what most of this stuff means. So I get this, let's see, 3. Since we're rendering to this texture, we need the render attachment flag to it. Yeah, but what does texture binding mean? Did we use this when we were creating the image? Oh yeah, it meant that we're going to be using the texture in rendering. Not like in rendering, but in shaders. I think. At least I remember so. Oh, also don't forget to return self, texture, view, sampler. We definitely don't need a sampler for a depth texture, but our texture structure requires it, and we need one if we ever want to sample it. Okay. If we do decide to render our depth texture, we need to use compare function less equal. This is due to how the sampler comparison and texture sample compare interact with the texture function GeoCell. But we're not using GeoCell. Maybe mistyped. Okay, let our depth texture be equal to a texture of type texture, create depth texture, device config. Okay, let's go to our state new. Where are we creating our other textures? Here. Let depth texture be equal to texture, texture, create depth texture, device label, depth texture. So depth stencil, we're finally going to be setting this. They teased us with the depth stencil like in the surface chapter. Finally, we're going to be using it. So WGPU, depth stencil state. Our format is going to be texture, depth format. Depth right enabled. I guess this is going to be like if you write to the texture, to the depth texture or not. Let's see, we can check. If disabled, depth will not be written to. Oh, okay. Not the texture, I guess. Depth compare, same compare function, stencil, WebGPU, stencil state default, and bias also default. Okay. The depth compare function tells us when to discard a new pixel. Using less means pixels will be drawn front to back. Here are the other possible values for compare functions that you can use. Undefined, never, less, equal, greater. I want to test out these two later, equal and greater. not equal, greater equal, always. There is another type of buffer called a stencil buffer. It's common practice to store the stencil buffer and depth buffer in the same texture. These fields control values for stencil testing. We'll use default values since we're using a stencil buffer. We'll cover stencil buffers later. Later is coming soon. Oh, it was recently updated. Oh, I guess it is being updated. That's a nice thing. Because I was worried that this is not getting updated. Because after this, I'm planning on adding post-processing myself from some examples I've seen. And I'm really not sure how to do it. Well, we'll see. Anyways, I'm gonna have to continue this project on my own if I want to do the thing that I wanted to do. It's not like it's gonna teach me how to make an engine here. Okay, pixels depth. What? Okay, so in our state, again, wrong one. In our state, we don't use number of vertices anymore. Oh yeah, because we're using indices to draw. I probably don't need it. I'm gonna keep it. Depth, texture. Texture. Oh, it's just texture. Nope, I need to do texture, texture. Okay. So then we also have to return the texture. Where is it? So after diffuse texture, depth texture. Oh, now resize. Oh yeah, because depth texture takes... Oh, this is useful actually for the future. Can I change this format to color? Which formats are there? Okay, let's return the one which was here. I want to check which other formats are here. Red channel only. Oh yeah, it's probably not called color format, it's called RGB. That's good because that means that we will be able to get the texture of our screen this way. I'm gonna have to create a new thing here. And then using that, we'll be able to then draw that texture to the screen. So we're gonna apply shaders to the texture. Wait, no. We're gonna like render everything. Then we're gonna apply it to the color texture. I'll find a way to do it. I'm not that stupid. Okay, let's see. In our resize, where is resize? Here. We do self dot depth texture equals a new texture from, oh wait, no, it's just create depth texture. Device, it's a reference to self. Device config is a reference to self.config. Label is going to be depth texture. Depth stencil attachment. We're gonna attach render past stencil, render past depth stencil attachment. Yes. View is gonna be self.depth texture view. Depth ops is gonna be some WGPU operations. Load is gonna be WGPU load operation clear. It's gonna clear it with white color. Okay. Store WebGPU. I'm gonna store it. Okay. stencil operations, none. And that's all we have to do. No shader code is needed. If you run the application, the depth issues will be fixed. If we run the application, let's run the application, cargo run. Okay, let's see, is the problem fixed? Yep, as you can see here, in the edges, it no longer draws in front of it as it used to. Amazing. I wonder, just as a small test, if I set this to 100, I just really want to see how this looks. This looks so cool. Oh my god. Let me move a little bit like this, so I can see all of them. Oh, I can't, yeah, because all of them are rotated differently. This is so beautiful. Let me take a screenshot of this. Okay, that's enough fun. Let's go do the hardest thing. Actually, no, it's not the hardest thing. The hardest thing is working with lights. I hate lights. They're so difficult for no reason. They're just literally shader code, but I don't know what that shader code is really difficult for me to understand. So yeah, beautiful. I love this. And it's so fast because you look at that and you think, oh, that would run slow because there are like so many of them, but it runs perfectly well. I mean, my PC is not powerful. It is very powerful, so I guess that also helps. Up to this point, we've been creating our own models manually, which is stupid. While this is an acceptable way to do this, it's really slow if we want to include complex models with lots of polygons. Because of this, we're going to modify our code to leverage the object model form. That's so cool because I wanted to do the object format actually. Why? Because some people would recommend GLTF. It's another texture format. Why people usually use it is for animations. But for the animation thing that I wanted to do, I wanted to use objects because, okay, let's close this. I want to open this in incognito window because, yes, I have no idea how to open incognito. Oh yeah, the incognito window. Okay, so let's go to YouTube. Why I wanted to do this is because let's go to GDH. This guy, he's making a game right now. 4 months of this video. Okay, cool. Ad. I love ads. Can you just be faster, please? Please, please, please. Okay, well, I'm not going to be showing this, I guess, as ads are stupid. Ctrl-Shift-P opens incognito tab. Yeah, thanks. Now I will know that. Actually, thank you. So what I wanted to show is that basically he does animations by storing objects in a vector, and it has a very nice feel to it. Like the 3D animations feel like 2D animations, like they're frame by frame, and I like that feel. So I'm also going to be going for it. So it's a good thing that it's not going to be doing GLTF, as it's also incredibly difficult to pass compared to object, yeah. Our librs file is getting pretty cluttered. Let's create a model rs. Sure, why not? Model.rs. Let's go to our mod.rs and don't forget to public mod model. Pa 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 do. Our librs switching in the. Okay, let's go to our state. Go to the end, go to our vertex thingy. Okay, I guess we are going to be keeping all of this for now. Fine. So we create a trait, a vertex trait. Can you have vertex traits with the same name as? Probably. So it's going to have a description function, WGPU vertex, buffer layout, static, blah blah blah. We've already done all of this, so I'm just going to copy this. And we. Oh my god, it's the guy who I still have no idea who that is. Like, actually. I have a feeling it's someone from the servers, but it might as well not be, which is even better, because that means that people actually come to my streams. I'm Mr. Digit, what? Who is Mr. DJ? Oh, it's you! I know you. Yeah, it's 2 letters. How can't you read? Yeah, okay. Okay, thank you. Now I know that I can't read. Amazing. It's not that I couldn't read, I just started reading and then I read it to myself, I guess. So, just copy this. And I guess we're gonna do this later. Yeah, hilarious, I know. Okay, let's see. You'll notice a couple of things here. In librs we had vertex as a struct. But here we're using it as a trait. We could have multiple vertex types. Model, UI, instance, data, etc. Making vertex a trait will allow us to abstract out the vertex buffer layout creation code to make creating render pipelines simpler. That's good. Another thing to mention is the normal field for model vertex. We won't use this until we talk about lighting. Yay, I love normal mapping. It makes everything look so much cooler. Like, in my opinion, most 2D games should use normal mapping, but again, it's a style preference. So I get why games won't use it. But yeah. As you can see, this is a lot of shader code. In shader code, I have difficulty understanding it. I would say that's my biggest problem in graphics programming. Okay, let's see. Okay, I read through all of this already. So for model vertex, we're going to be implementing this. I'm going to do it my way. So we're going to create a constant attributes. Oh wait, is it also gonna? I think it's probably not. So it's gonna be a WGPU attributes vertex attribute. It's gonna be sized. We need 3. Okay, and it's gonna be equal to WebGPU vertex attribute array. Let's put this on the next line. What's normal mapping? Normal mapping is a technique which allows to give textures depth. So for example, let's just go search normal maps. Images. So they look like this, they basically specify where the light will be lighter and where would it be darker. And it allows us to make 2D textures look like 3D textures. So like you don't need many polygons, you can just use a normal 2D texture. There's like some example here. Normal maps versus no normal maps. Yeah, without normal mapping. Wait, let me open this so it's... Can I open it like this? No, it's still gonna be a link. Can I open it like this? Yes. So as you can see, it's pretty bland without normal maps, but when we do normal maps, it... Oh, this is the image. Let me take this. Yeah, but with normal maps, it's like detailed, you can see different cracks, like the wall has actual, like, almost feeling to it, and you don't need to use any polygons for that, you don't need to do a lot of models, it's just a simple texture. It can also look really good in 2D, so 2D, let me search this here, 2D normal maps. In pixel art, I mean. For example, let me just show you a game. Dead Cells. This uses normal maps, and you can see like all of this has a slight 3D effect, and it's a little bit thanks to the normal maps. So yeah, it's cool. Okay, so let's see. We specify our location 0 to be a float 32 by 3. We specify our 1 to be float 32 by 2. And we specify our 2 to be float 32 by 3. And this here. Does Hollow Knight have normal maps? Probably it does. It's a 3D game, so... Or maybe it doesn't. Yeah, it probably doesn't, if you don't find any normal maps looking like this. It's probably all just textures. And lighting. Which is enough, don't get me wrong, normal maps are not something which is absolutely required. Nope. It is. If you don't believe me, just search how Hollow Knight was made. It's 2D, yeah, sure, but it is made in a 3D engine, and it's technically 3D. So, yeah. It uses some special stuff for it to look 2D. It is 3D though. It is sprites. Sprites are two-dimensional. Okay, just... Is Hollow Knight 3D? It was made in a... with 2D assets layered in a 3D environment, so technically it's a 3D game. So, shush. The gameplay is 2D. It doesn't mean the game is 2D. Unreal Engine paper games. This also has 2D gameplay, but you can move like everywhere. This game, I like this game. Yeah. It's in a 3D world, so... I mean, again, it's specifications. It's a 2D game, so yeah. I guess you can still say that. Okay, so why do I have a problem here? Does it not know what WGPU is? It's not a member. So like this. Okay. Bruv, okay, let's stop with this talk. It's made in a 3D environment. It uses 2D sprites. It can be 3D, it can be 2D. technically Dead Cells is also 3D because there, actually all the sprites are models. Just using a shader, they become 2D. Isometric view in a 2D engine. I mean, depends on. You can do isometric view with 3D models, or you can do just with in a 2D world as well. You can do in both. That's why it's called 2.5D, actually. If you don't believe me, 2.5D games. Yes, isometric game 1, isometric game 2. This is also an isometric game technically. A lot of these are isometric games. Okay, let's actually continue doing what we're doing. So this repeats again. It's just a memory size of our model, vertex as WGPU buffer address, step mode, vertex, step mode, vertex, and attributes are going to be equal to reference to self attributes. Okay. Actually, I don't think I will be able to use it like that. Oh wait, no, I will. Okay, no, everything is fine. Oh my god. Good song playing again. All of Undertale songs are good. This is like the 5th time me saying, and this is like my 5th stream ever. So yeah, that's funny. So in the render pipeline, we're gonna have to specify the model vertex. We're gonna have to, oh yeah, I already talked about this. We are gonna have to create for each model. So let's find where we create our render pipeline. That's here. And here let's edit the code a bit. So let's find this. Where is it? Here. Okay. So instead of vertex description, we're gonna be using model vertex description. I'm gonna have to make this public as well. I think that means that I'm gonna have to make it public here. Huh? How do I... Does this public work? Nope. Then why isn't it working? Let's see. No function of associated name description. What am I doing wrong here? Model vertex. Do I need to implement this? No, I don't. It probably already implemented itself, right? Yep, it did. Oh, I need to make, no, it is public. Okay, what if I do it with this function? Is it fine now? Nope. What? No function or associate item named desk would found for struct model vertex in the current scope. Only if that trait is in scope. That means takes in the model vertex description I am so confused with what the error is. It is public, so it should be visible. Do you need to make it a public implementation? I don't know. Oh, what could this be? Oh, there's gonna be zing. Okay, let's close all of the stuff I don't need. I need this, I don't need this. I might need that still. Okay, let's not do this like that, and then just... Actually, wait, don't remove it, just comment it out. And comment out this one and this one. I can uncomment them, right? Yeah. Okay. So instead of so.attributes, I just copy this. So I don't like how it uses this here, so I'm gonna put it at the top here. Is it still the same issue? Since the desk method is implemented on the vertex trait, the trait needs to be imported before the silly. Okay, so that means that I just need to set use for model. Just do model and comma model texture, actually not texture, vertex. I should just do for all, not just for the vertex. Accessing files in the resource. I'm back. People living in the same house issue. Okay, let's see. So, an error has occurred. What? No. Specifies this as So I'm not gonna need any of this. And let's open the code real fast. Source R model rs. No, not model rs. Lib.rs. Okay, so it just deletes it. Does it keep the structure vertex though? Nope. So I can just take this and delete all of this. Now there are going to be a lot of errors for a while here, but I can deal with that. Okay, let's close this and go to accessing files in the resource folder. When Cargo builds and runs program, it sets what's known as the current working directory. This directory usually contains your project's root, cargo.toml. The path to our resource folder may differ depending on the project's structure. In the resource folder, the example code for the section. When loading our model, we could use this path and just append cube object. This is fine, but if we change our project structure, our code will break. We're going to fix it by modifying our build script to copy our res folder to where cargo creates our executable. And we'll reference it from there. Create a file called build.rs. Where do I make this? I guess I make this in the normal one. So new file. I thought your home was invaded. Nope, it was not invaded. What? Why is there a heart there? It looks like an Undertale heart. What is this song? Oh wait. Why did random songs start playing? That is not good. I'm already scared of copyright strikes. Okay. Use anyhow. I'm just gonna copy all of this and read it. So copy items, use fs extra. Print line cargo return if changed resource. Let out directory environment variable out directory. Let mute copy options new. Copy items, paths to copy, out direction, copy options. What? Output direction, paths to copy. Options. Okay, I think I understand what it does. You need to modify your cargo toml. Wait, make sure to put build rs in the same folder as cargo toml. Okay, so you need to put it here. Yep, move. Cargo won't run it when your crate builds. The out directory is an environmental variable that Cargo uses to specify where our application will be built. Isn't it usually built in debug, build, and then... No, it's not this. Oh, this, yeah. Oh, okay. You'll need to modify your cargo toml. For this to work properly, add the following below your dependencies block. I already have anyhow. I just need fs extra, the newest version, and glob. I have no idea what these are. Oh, don't forget equal. Let's see, accessing files from WebAssembly. What? Oh, I'm not using WebAssembly. Haha. Look at all these WebAssembly users trying to have to do all of this. Could not be me. Okay. Loading models with TOPG. I guess this is type object. It stands for that. Let's create dependencies dot TOPG. Let's make the version newest features async. What? Why did this get deleted? Okay. Not okay. Okay, what if I just do it like this? Oh my god, stop deleting it. Features, async. Okay. Oh, I think I forgot to make an array there. Well, that's still fine. No, it's not fine. Something is not good. Let's just let it build. Oh no. Oh, okay, it's because of this. Oh, why is it because of this? What is happening here? Hmm. Okay, let's download this. Oh, oops, don't view raw. Okay. That's fine, let's show in folder. Let's extract this real quick. To here. Wait, not here. Wait. Yes, here. Wait, no, not there. Where the hell is... Oh, okay. Rust macros. Oh, that's gonna change so many things though. Why do that? Do I need it? I don't need it. Right, it's not like something very specific. I'm still gonna have to specify the path. Yeah, and then it uses resources load model. Okay, come on. You're creating this for WebAssembly. Okay, this is getting annoying. Where is the load model? Wait, what? It's not even here. Load binary, load string. Oh, it creates them. Okay, I got mad for literally no reason at all. So I guess I'm just not gonna be using this file. Yeah, I don't need it. I'm gonna just create a folder for models for now. Okay, so let's see. Let's go to model. Oh, we create a new struct, call it a model struct. Our public meshes. Okay, meshes. It's a vector of mesh. I guess we're going to be creating that later. And public materials is a vector of material. Let's create struct material. Oops, material. It's going to have a name. It's going to have a diffuse texture. is gonna have a bind group. And we're gonna have also, let's put them below. We're not gonna implement functions for them, so yeah, I don't see a point in bringing them to the top. Let's create a public struct mesh, not material. It's gonna have a public name string. Oops. We're gonna have a public vertex buffer. It's gonna be a WGPU buffer. Also an index buffer. Number of elements. And the material, which is a usize. Also, where is it defined as well? Tell me. Oh, in WG. Well, how do I call this? I don't know. Material. I'm just gonna call this model material. And this like this. So then this is gonna be here, and this is gonna be here. Also in here, I just realized that we're probably not gonna be needing these guys. Actually no, before I delete them like this, I'm just gonna comment them out. Let's see, so we comment this out. This. And then in the top here, we don't need this, and this. Okay, and that's gonna be changed, so right now I'm not gonna be messing with it. Let's see, so speaking of textures, we need to add a function to load a texture in resources. I hate the fact that this tries to do it simultaneously for web as well, because like, okay, you don't want to access files from WebAssembly, so that means that you just want to skip this part. Well, sick. Well, it turns out that you should have created another file named resources. Like if I didn't by accident see it with like my third eye, then yeah, I would have probably not noticed that. Okay, public mod resources. Let's use that. So it's a sync function, load texture, file name, it's gonna be a string, device, oh my god, WGPU device, okay, so we're going to return a texture, let data load binary, file name. I guess this is something that I have to implement myself. Yay, amazing. Texture from bytes, device queue, this is data and file name. This does return a texture though. Expected enum SED result found unit type Quick fix. Oh my god, as soon as I open the window, someone starts building a house. Oh, oops. Cannot find function. Let's see. Load binary. Yeah, I ain't reading all of this. Why does it do it? So it says loading it for the WebAssembly, but at the same time it puts the code here, which is not for the WebAssembly. So as you can see, if it's WebAssembly, then do this. Otherwise, do this. That's just absolute BS in my opinion. I know I'm not the one writing this and I shouldn't get angry at them, like, still. Create, no, don't do any of this. Do I need this CFG? Yeah, I do need it. Okay, I'm gonna be using any of them. Okay, it does use load string, it does use load binary. Does it use load, oh, those are the only two. Okay, so I don't need this. What is CFG if? Oh, no, I don't need this because I am not going to be doing this like this. I'm just going to delete all of this, delete this, and do it like this, right? Okay, so I still have to define it. Oh my god. I don't think I will be able to do this. Okay, so let's create a file, build.rs. Where's this code for it? Up here. Just copy it. Yeah, well I did, but it still returns errors. Come on. And this has to be specified as an anyhow result. Remove this. But it's still just like doesn't know where they are. Oh, build dependencies. Oh, I didn't see that. Oh, that makes a lot of sense now. Maybe. Yep, at least it fixed that. Oh, that was just me being blind. Okay, that's on me. That's on me. Let's see. The out directory, not set. How do I enable build scripts? How do I enable build scripts? Let's go here. Let's add a resource folder first of all. Okay, let's open this code. So this is all the cube stuff. Cargo Tomo. How do I specify that it should be? Enable build scripts to fix. Maybe something like this, lib build script, nope. Enable build scripts to fix. We follow the instructions here. There has to be a similar, easier solution. Okay, let's hope this guy is correct. Just restart it. Okay. Let's see. Nope, it did not fix. Oh, it did fix it. Wow. I love when stuff fixes itself. Just because I decided to click the restart button. So now everything works. Okay, yeah, this is good. Oh, this was way too much stress. Not stress, brain problem. Okay. Join rest. Wait, where is this? Oh, it's here. Okay. Let's see. Just so I'm sure that everything works fine, let me... Oh, it's gonna return an error. Okay, well, I guess I'm gonna find a way later on when I actually run the project. Let's close... Okay, I'm not gonna be closing any of those. With all out of the way, we can get to loading our model. So... I guess I do this in resources again. Let's see. We create a public async function, load the model, and gets the file name, string, device, queue, layout, which is a WGPU binary group layout. This shouldn't be that difficult. It should probably be most of the stuff that we have already done before, just put in one function. I hope. Oh no, what is this? What am I seeing here? Okay, well, let's start and try to understand this as we go. So first we create an object text that's just going to be our data that we load. So we load string, file name, dot await. Wait, shouldn't it use... I think what I'm gonna have to do is the same thing that I did here. Oh, it's not an app? I guess it's in main then. Yeah, block on. Okay, let's see. Everything that has a wait, this is an async function. What is asynchronous here though? Let's remove and see. Okay, for now we're gonna copy this out. Wait, nothing is asynchronous here. and nothing is asynchronous here. Wait, no, it is. Load binary. No, it's not asynchronous. I guess this could be asynchronous. Because I don't want to use async. Let's see. Comment. But can I just select all of this and do control this? Yep. And remove, oh wait. So none of this is asynchronous. Oh, I just removed some string. This is supposed to be here. Wait, so none of this needed asynchronous. Okay, cool. And then we don't need this here. Okay. It says that where it's possible, I want to use, wait, cursor, block on, so because I've used it before and I'm more comfortable with it. So create a new object cursor. We let our models, object materials. Buffer. Asynchronous. Okay. So if we do this is asynchronous, let's do mutable object reader. This is gonna be WG load options, triangulate true, single index true, and everything else set to default. This. Oh, then it needs a lambda, I guess. Do a buffer reader, yeah. Okay, there are about to be some errors that I should fix. Let's see, this is mat text. So there's a comma after this, just for beauty's sake. Like this. So this should return, oh my god, 2 dots by accident. This should, okay, for now I'm just gonna remove this. Actually I can't. What does it return in the end? Okay. Auto meshes materials. Okay, well, let's see. Expected 3 arguments. Wait, first of all, block on. Can I use this here to do like this? Oops, did it in the wrong spot. Wait, so it passes expected 3 arguments, found 4. Oh, it's with the return value. Okay, it doesn't like the return value. Okay, I guess everything else is fine, which is weird. Let me just do, just in case, block on. Can't find import poster block on. Yeah, still the same error. But wait, if I do to do, the error should disappear, right? Nope, it does not. Okay, let's create immutable of materials. It's a new vector for M and object materials. Let diffuse texture, low texture, M dot diffuse texture, device, Q, let bind group, okay, at least this is a known territory for me, the bind group descriptor. We've made so many already. Okay, let's scroll down. So it's going to be the layout. Entries are going to be this WGPU bind group entry binding 0 resource WGPU binding resource texture view diffuse texture dot view. That's the only thing that should be passed. Yep. And WebGPU another bind group entry. It's going to be a binding 1 resource WebGPU binding resource sampler diffuse texture dot sampler. Okay. Comma no label. Oh, I need to do materials push model name M name. That's it. Why does no not M? Yeah, M. Diffuse texture bind group. Something is not correct here. What is it? Okay, let's just copy this. I think I might have missed. Oh wait, I forgot. It's just stupid. Should I? I'm just gonna copy all of this. I cannot even start to understand this. It's no, just no. Nope, no. What? Oh, this is one line. Oh. This is a one-liner if I have ever seen one. Jesus Christ. At least I understand this part. That's good enough, right? Okay, we're gonna return model, meshes, materials. Please don't be mad at anything. Yay, you're mad at everything. Oh, because I called them model mesh. I'm gonna have to copy this everywhere. Oh, I'm not. No, here, yep. Oh, so I did expect 3 values. Let's see. Where is this? Cursor mat text. What expected 3 values? This got 3 values. Object reader, this. Let's not make this async. I don't want to make this async. remove all of this stuff off. You might have meant to open the body of the closure. Let's copy this. Maybe I wrote something incorrectly here. Return, delete this, delete this. Does it need async? Nope, it doesn't. What's the problem? Okay, can I make this an async function without having to make any of the others async? Oh, it's supposed to be public async. I can, which does make all of this easier. Wait, what? This is when creating the material, low texture, diffuse texture. Yeah, why does it pass in the texture? What? What? Name? I don't know. And where is object materials? Materials is a vec of model material. Yeah, because why would you pass in the diffuse texture here? That makes literally no sense. Maybe it meant... Does anything here get... Nope, nothing. Maybe it meant to say texture load texture, but that also... Firstly, there isn't such thing, so I'm not even gonna bother with that. Seems to work. I mean, doesn't seem to work. Seems to not give me an error, which is good enough for me. Okay, let's try to speed through this. Before we can draw the model, we need to be able to draw an individual mesh. Let's create a trait called... Oh, first I need to also go to my downloads. Did I already extract this somewhere by accident? Nope, that's good. Okay, so select this, extract... No, not here. Okay, that's also fine. Oh, distracted. No, not here, please. Extract to cube. This, okay, that's good. Then just copy these, go to resource. Can I do this? Yep, I can. Oh, 5 viewers. Oh my god. Wow, people are watching me suffer. Trying to understand this. Okay, I'm gonna try to suffer more then. Okay, let's see. Drawing a model. Oops, someone left. That's sad. Okay, draw model. It's gonna have lifetimes. Who doesn't love lifetimes? It's gonna draw mesh, mutable of self, mesh. Why does he need a lifetime for the mesh though? I don't get that. Man, function draw mesh instanced. So let's see. This is gonna be mesh instances. Gonna be a range of U32 like this. Yay, errors. First of all, this is supposed to be model mesh. Yep. This is a different name, I forgot about that. But range, I think I just need to implement, yeah. Oh, I need to specify which one. Yeah, probably that one. I know what this does. The only reason, why can I not do it? Does this require a lifetime by some chance? Maybe it doesn't. Okay, I'm back. I have to go in 30 minutes because, yes, life is, yes. So let's see. I can do it without a lifetime. Does it need a lifetime? Okay, I'm just gonna remove all the lifetimes and see where this gets me. So remove where, remove this. Render pass. Can I do static here? I can. So then just do model mesh here and model mesh here. I think this will work. I hope this will work. Okay. We could have put these methods in an implement model, but I felt it made more sense to have the render pass do all the rendering, as that's kind of its job. This does mean we have to import draw model when we go render though. When we remove vertex buffer, etc., we also remove the render pass setup. Why should I still have render set vertex buffer, diffuse bind group, camera bind group, okay, yep, render pipeline, instance buffer. Okay, I don't then need any of these guys. Sorry. And using model, draw model, render pass, draw mesh, instanced. We're gonna draw a self, model, meshes, 0. let's see. So it's 0 to self instances dot len. Oops, len. And oh, what? As U32. Okay. As U32. And never forget the semicolon in the end. Okay, so this is going to return an error, obviously, because we need to create that. Let's close this. I guess we're not going to be needing these guys, so I am going to delete them. But we are going to need our object. We are going to save it, right? No, we're not going to save it. Okay. Why did I skip something? How does it get solved at object model? Yeah, we're gonna have to add it here. Object model is gonna be model. Right, okay, yeah. Now there's an error here. In the very end here, let's create an object model, which is gonna be resources, load model. Technically it should be the same as here, so cube.object device queue layout texture bind group layout, and it's gonna do before it does this, I need to do block on, this is and then I unwrap this. Right, this is hell of a line. Let's go here. Okay, we're almost finished with this. There are no errors here, right? Yeah. Just have to return the object model. Our new model is a bit bigger than our previous one, so we're gonna need to adjust the spacing of our instances a bit. Oh, really? We create a new const space between, and I'm just gonna copy this. Our instances here. Oh, I didn't copy all of it. Copy this, paste it here. This is a state instance. And yep. Where's the error? Two problems in this file. Where are they though? Oh no. Not. Recorder does not live long enough. Borrowed value does not live long enough. Dropped here while still borrowed. Okay, yeah, I think I'm gonna actually have to do all those different lifetimes. So let me just copy this and put model mesh. Right, yeah. Stupid encoder, no one likes you anyways. So we draw this, we do that. Let's see, predictions on how many errors I will get. I mean, probably one, then it's gonna crash, then another one, then it's gonna crash again, then another one, then it's gonna crash again. Or something even worse can happen. It's not gonna give me any errors, but nothing is gonna draw. In which case, I'm gonna be very sad. Okay. Result unwrap on an error value. State RS, line 158. Huh. It actually returned an error. Let's see where. Let me guess, it returned an error here. If I do unwrap here, it's gonna crash there. Panicked. Oh, either doesn't say it. Where did it fail though? Well, I just used AI to cheat in a Minecraft puzzle. Good job on using less of your brain. Let me just find every question mark and replace it with unwrap, because that way it's gonna tell me where it failed to unwrap. Because question mark is unwrap or default. Okay, those don't need to be. And I guess it has a default value, so it chooses the default value instead of giving me an error. Okay, we found the error. Okay, so the path is incorrect. Let's print out the path name. Print line, debug print please, and path. Where is it? Rust macros target debug. Oh, it tried to go to target debug build. What if I remove this and just leave it res like this? Nope, it cannot be. Well, what do I do then? Let's go to build. I don't even know which build this is. 289 of this one. And it tried to find out resources, material .001. Let's see. If we go to source code real fast, where is it? Check out the code. Resources. Why did it try to find material .001? Material 001. Builder S. Yes, this is the same. I literally copied that. out direction. Not direction, directory. Join resource file name. So this happens in where again? Right, this function. So let's go to where we do load binary. We get in the file name. Let's print out this. Debug print. Yep. It's 289. Okay, so it does find it. But then, okay, let's print file name. Connect for install block 3 chance cubes. Also, I think I'll go sleep now. I feel tired. Okay, well, good luck sleeping. That sounded very not how I wanted it to sound. So, like, yeah. Good night, I guess. Also fix your sleep schedule. Because I know what time it is for you right now. You should not be sleeping. So, material 001. Why is it material 00? What? That is. Just what? What? How does cube.object become material 001? Cube.object. Is this what it's called? Yep. Let's pass in here. What? Okay. So it What? What is the problem here? Okay, let's add CFG if and just stupidly copy the code. Oh, what? Oh yeah, sorry. Okay, let's see the toml file then. CFGF1. Okay, fine. Model loading. Just copy all of this. Even though it's absolutely the same thing, but also for WebAssembly, maybe I did something wrong. So this should not be asynchronous, this should not be asynchronous. This should be asynchronous. Yep, CFG. Oh, okay. Use CFG if, CFG if. Cannot find. Oh, I I accidentally deleted my other function. Oops. Put it here. Okay, and then do use cfg if, and remove, where is it? Yeah, remove all the asynchronous stuff, as I do not need it here. This probably won't fix anything. Let's just still print line. What if we don't do it if debug print? Maybe that messes up something. I'm not sure. Cube object, cube MTL. Oh, that's load string. No. We need load binary. Because this is the one which breaks for some unknown to me reason. Bruh, material. Oh my god, what? So it's not a problem with what I did, that's for sure. So we turn this back to how it was. Man, I have to go soon. And load binaries broken for some reason. Does it need to be an async function maybe? It's not gonna help, but still. Oh my god, material 01. Oh yeah, don't do debug print, yeah. Let me try it without debug print. Yeah, I don't... What? Why does this get converted? But it still does use the file name. Yeah, well, I am gonna fix this later. I do not think that I have, not that I don't think, I don't have any time left for today. So we're gonna be ending on a very weird and strange error today. But still, thanks everyone for coming, who was watching here, this stream. Yeah. I'm gonna go do something else now. Thanks for joining in.